Hi all, welcome to DHS Informatics. In this video, we are going to discuss about confusion matrix. Usually, this confusion matrix is used in machine learning classification project for performance evaluation. That means result analysis they will use. You develop one model and it will be classifying the objects, or it will classifying a text or music, video, something. How much accuracy it is having. To find out that accuracy, we need this classification matrix. Confusion matrix. Actually, this confusion matrix will be used in machine learning as well as deep learning. In classification project it will come. It will not come for the prediction projects. Before entering into further discussion, if you are not subscribed our channel DHS Informatics, I am requesting you to press the red color button below that subscribe button and press the bell icon so that you will get our next updates. Thank you. What is confusion matrix? A confusion matrix is a table that is often used to describe the performance of the classification model on a set of test data for which the true values are known. It is like that you are writing a test. I am going to verify that what is your mark means I should know the correct answers. Objective test you are writing means without knowing the answer I can't able to evaluate your answers. No, like that. For that only we need the true values also should be known. That is the main thing. How the confusion matrix will look means it will look like that you are seeing on table in this slide, no, like that predicted no, predicted yes, actual no, actual yes, like that it will be there, no, like that only it will be look. Consider the confusion matrix for the binary classifier. This table is for the binary. Binary means yes or no. Sometimes we can able to do with more than 2 means it is possible. For example, you are going for animal classification. You are giving one image. It may be a cat, dog, lion, tiger. Like that we have to classify means it will be 4 by 4 matrix or 5 by 5, 10 by 10 also it is possible. Okay. For simple explanation, we are doing with a binary classification. That means yes or no. Mostly the confusion matrix explanation we are giving with comparing with the disease model. I am going to tell you about that in detail. For example, there are 2 possible predicted classes, yes and no. If we were predicting the presence of a disease, for example, yes should mean they have the disease, no should means they don't have the disease. It is simple only. For easy understanding only we are explaining the confusion matrix is the disease. That disease may be anything. It may be COVID-19 or it may be a heart disease, diabetic, thyroid, any disease you can keep up. The example what we showed in the previous slide, there is a 165 prediction sample we are giving. You can see here there is a n is a 165. Okay, in that 165 you can assume that totally actually how many people are having they are not having a disease means no means 60 people are not having a disease actual, and actually they how many people are having a disease is 105 people are having a disease, and 60 people are not having a disease. That is the actual input we are giving. Totally 105 plus 60 is 165 we are getting. But this model is predicted among that 16, 50 it is predicted correctly they are not having disease. But it is predicting 10 who are not having a disease, it is predicting they are having a disease. Here actually 105 are having a disease, it will predicted yes for 100 people they are having disease, 5 people it is wrongly predicting they are not having a disease. Maybe you can able to understand 105 patients are having a COVID-19. It is predicted 100 people having COVID-19, but 5 it is telling they are not having COVID-19. And here 60 people are not having a COVID, but it is predicting 50 are having a COVID and there is no COVID, and 10 people are having a COVID. Like that is predicting. This only explained here. Out of those 165 classes, the class we predicted yes 110 times and no 55 times. That means yes 10 plus 100 110, no 55. That only they are telling. In reality, 105 patients in the sample have the disease and 60 patients do not. That I already explained you. Hope you understand. Okay. You want one more time? I'm telling you, 60 people they are not having a disease, 105 are having a disease. That is actual. This is a predicted. Here it will come. You should understand this term. True positive, true negative, false positive, false negative. These four terms are very, very important. You can simply, you understand the logic, you will easy to remember. True positive. There are cases in which we predicted yes and they do have the disease. That means really they are having COVID-19. We are also telling they are having COVID-19. That is a true positive. So that is clear. Next thing, true negative. We predicted no and they don't have the disease. We are telling them they are not having a COVID-19. They are also not having a COVID-19. That is a true. So that whenever true is coming, it is correct. You can able to imagine. False, whenever coming, it is a error. We can able to say. Okay. In the error, there are two types of error. Type 1 error, type 2 error. We can see. What is going to be false positive? We predicted yes, but they do not actually have the disease. We are telling one person is having a COVID, but that person is not having a COVID. It is a type 1 error. And we predicted no, but they actually have the disease. That is a false negative. It is a type 2 error. So that which is danger? We predicted no, but they actually do have the disease. That is, I am telling one guy is not having COVID-19, but he is having a COVID, means it is a very danger. No, so that in this case, type 2 error is very danger. But type 1 error, the person who is not really having the disease also go for a quarantine. Correct? No? Like that it will come. So that I have added those basic terms to the confusion matrix and also added the rows and column. You can see it is a true negative. That means they are not having the disease. True positive, they are having a disease. False positive, that means they are not having a disease, but we are predicting he is having a disease. Similarly, false negative. False negative means he is having a disease, but we predicted that he is not having a disease. Like that. Here, in the confusion matrix, there is along with the confusion matrix, usually you will get one more thing, classification report. In the classification report, they will call precision, recall, F1 score. These three things will come. Precision is nothing but an accuracy. How we are calculating the accuracy means true positive plus true negative divided by total. In this table, true positive and true negative will be how much we are having the thing. 50 plus 100, 150. Total values are 165. So that we are having a 150 divided by 165. That means 0.91 we are getting. That is 91% we are having accuracy. That is then one more thing, misclassification rate. We are having 91% accuracy means definitely 0.09% is the error will be there. That is a false positive and false negative. We are adding, we are getting 0.09. Okay. This is one thing we can able to tell. Okay. It is called error rate. Another thing, true positive rate. True positive rate means actually how many people are having a disease and how many people we detected. Actually they are 105. We predicted 100. No. So that 0.95. That is called the recall value or sensitivity. We can name it anything. So that our thing we can able to say in accuracy it is coming 91%. But recall is 0.95. That is disease correctly we are predicting how much percent? 95%. Like that we can tell. And a true negative rate. How many people are going to affect when it is actually no? How often does it predicted no? Like that. That is a true negative divided by actual loss. True negative divided by actual loss. Here you can do true negative divided by actual loss. True negative how much is 50. Actual loss are 60. 50 divided by 60. That is a 0.83. We can name it as it is called sensitivity and recall. It is called specificity. Like that we can able to say. And apart from that, there is some other terms also there. False positive rate. False positive rate means false positive divided by actual no. 10 divided by 100. This many people are really going to affect. They are not having corona, but they have to go for a quarantine. That is 0.17% going to corona or quarantine without corona. Like that. Then precision, I told you, it is nothing but an same. What is that? Accuracy, 91% only. They will term it same thing only. True positive by predicted yes. Okay. Then prevalence. Prevalence, how often does the yes condition actually occur in your sample? Okay. We are having out of 165, 105 they are having a disease now. So that prevalence is, there are 100 people are going for test, 64 people are getting COVID positive result. Like that we can able to tell. That is called prevalence. And one more thing, they tell F1 score. This is a weighted average of the true positive rate, recall and precision. That is a F1 score. Hope it will be clear. You will understand. You can watch this video 1 or 2 times so that you will get it clear idea. Thanks for listening this video. To handle your academic project easily, visit our website www.dhsinformatics.com, and you can send a mail to info@dhsinformatics.com, or you can able to call us 9886692401, 984516673. If you like this video, press like button. If you have any questions or comments, you can mention the comment. If you are not subscribed, subscribe this our channel. Share this video to your friends. Thank you.